So, good evening, everyone. Uh, so, in today's class, we will solve some of the problems that were asked by students earlier, and a few other problems also will solve. I think first we will solve. We will see on state space analysis. Uh, One of the students has asked one question that we will see. Then we will see the next questions. Let us wait for like 1 2 minutes so that others join. Okay. 6 5 will start. So, do you have any other topics to be discussed or any questions? So, as I said, you can mail me. I haven't get, I think, last 1 week or 2 weeks, I haven't get any new questions. Yeah, fine. Let us start. Good evening, everyone. Now we will see some questions from state space analysis. So this is the question. This question was given in GATE 2011 ECE for 2 marks. The question reads as follows. The block diagram of a system with one input U, and two outputs Y1 and Y2 is given below. So this is the input and these are the outputs. This is the block diagram. Then a state space model of the above system in terms of state vector and the output vector is. Okay. So this is on state space model. So you might have studied, right? I think you might have studied in control systems mostly, or else in network systems, these things. And also you might have heard of this digital electronic state, present state, previous state, these things. Okay. Let us briefly see about it, try to understand what is the state model, then we'll solve this problem. Can somebody tell me what is the state? What is state? Fine. So state space analysis, we'll see some basics. So this already, state gives the future behavior of the system based on the present input and the past history of the system. Okay, this you might have studied, right? In digital electronics also, see, you have seen the state diagrams especially for sequential circuits, right? So the output depends on what? Present inputs as well as past history of the system, that is past states, right? So this past history of the system is described by the state variables. Okay. So generally we describe in terms of state variables, the past history of the system. Okay. Let us say a resistive circuit is given. In network engineering, let us take a resistive circuit is given. Okay. Let's say that is a system. Only you have some resistances like this. Something like this. Input, output, some resistive system is there. Then right, resistance is don't have any memory, right? Generally a resistor is what immediately dissipates the power. in terms of heat. So it's a memoryless system. It cannot store the history, right? So there is like it cannot store the information about the past. That's why independent of past history. The present output is independent of past in resistors. And that's why there are no state variables for a resistive system. It is since it is memoryless. You as already you know. So what are the memory elements? You know, inductor and capacitor are the memory elements that you know, right? Inductor, you know, right? It will store the energy. Capacitor also in terms in the form of charge, and inductor stores in the form of what? So kind of magnetic energy, right? Inductor and capacitor are memory elements. They store the past history. That's why in a circuit, if you have inductors and capacitors, definitely you will have state variables. Okay, state variables represent the past history of the system, right? See, let us say through a resistance, let us say this is some kind of step voltage I'm giving. Let us say initially you have 5 volts and suddenly rise into 10 volts. In resistive circuit, suppose input if I'm giving, what will happen the output for resistive circuit? Let us say I'm measuring output current or voltage something. Response also will be like that only, suddenly changes. What about an inductor? Exponentially in inductor or capacitor, at capacitor voltage, let us say, it's exponentially rises, right? Or exponentially decays, depends on uh, like the input we are increasing or decreasing, right? Inductor current or capacitor voltage, these things you have seen, right? Okay. Now, suppose in networks, if a resistive circuit, if a circuit which is having inductors and capacitor, it will have state variables. Then how many number of state variables should be there? Let us say n is the number of state variables. Then suppose an electrical network is given, then the state variables is equal to the sum of inductors and capacitors. How many inductors are there? How many separable inductors and how many separable capacitors? Okay, it gives the number of state variables. Suppose we know any network system we can represent in the form of differential equation. If differential equation is given, then order of this, differential equation is nothing but the number of state variables. Okay, uh, is that okay? Is that clear till here? Anybody else has any doubts? Fine. Uh, Next, we'll see what is a standard form of a state model generally. So, state space analysis, a state space representation. If you see, so this is the standard form. Will represent like this. X dot dot means it's a differentiation symbol will represent it. Dy by dx as some d y dot something. Okay, equal to ax plus bu and y equal to cx plus du. So this equation is called state equation or dynamic equation, they will say. And this equation is called output equation. So x equal to ax plus bu and y equal to cx plus du. Okay, na? Here x is called state vector. Okay, this x is called state vector. This x and x dot this one is nothing but the differential state vector. Okay, see, suppose you have x, then x dot is nothing but dx by dx something, d by dx of dx something. Okay, na? So y is output vector. So this y is output vector and A is state matrix. So here A, B, C, D, these are matrices. X, okay, and okay. Also, I left one thing, right? U is the input vector here. Input vector. Okay, u is input vector, x is state vector, x dot is differential state vector, y is output vector, and A is state matrix. This A is state matrix, B is input matrix. So the matrix that multiplies state vector is nothing but state matrix. B matrix that multiplies input vector is nothing but input to matrix, and C is output vector. So in Y we are giving this C, Cx plus du. C is output vector and D is transmission vector. Sorry, matrix. C is output matrix and D is transmission matrix. Okay. And suppose in a circuit if there are no active elements, you know, right, what are active elements? Let us say a dependent source. In networks you might have seen a dependent voltage or current source. Let us say its voltage is some 2i something. You might have seen dependent sources like that. Any active elements are there, then you will have D matrix. If there are no active elements, then you will not have D matrix. D matrix will be 0. Then simply y equal to Cx only. Y equal to Cx plus du, right? Y equal to simply Cx only. Okay. Now, this is the state model representation standard form. Okay. Now let us say a multi-input, multi-output system. You take any complex network. Let us say it's multi-input, multi-output system. A black box I'm representing. So U1, U2 up to UM, these are called inputs. M inputs are there. And Y1, Y2, YP, P outputs are there. And X1, X2, so on, Xn, these are the state variables. Okay. So the state vector is what? X1, X2, Xn is the state vector whose dimension is n cross 1. Okay, n inputs are there. Sorry, n state variables. That means that many number of inductors plus capacitors are there. Or if it, yes, if it is a differential equation, that is equal to order of differential equation. Now u is what? Input. M number of inputs are there. It's the input vector. And y is output vector. P number of outputs are there. P by 1 vector. P by 1 matrix. Now if you see the state equation, x dot equal to ax plus bu. So u is n cross 1 we know, x is n cross 1 we know. So x and x bar, x dot should have same dimension, because if x is this one, x dot should be this one, x1 dot, x2 dot, x3 dot, just differentiation. So they should have same dimension. That means x dot should have n cross 1 only. X is state vector is n cross 1. So differential state vector order also n cross 1. Now to get n cross 1, what should be the order of matrix A? If it is n cross n only, right? For differentiation, sorry, multiplication to possible, these two should be equal. The order will get n cross 1 this time. Second time if we take, again it should be n cross m, because we should get n cross 1 as output, then only we can add those two terms. These should be equal. So that's why A order is what? A order is n cross n and B order is n cross m. Okay. Similarly, if you see Y, uh, output vector, x is n cross 1 we know, and u is m cross 1, that many inputs are there. Then y is p cross 1. So then what should be the c dimension? It should be p cross n, and d dimension should be p cross m. Okay. So this is some overview about state space representation. Any doubts? Any doubts? Fine. Let us see one example, then I'll solve that problem. Okay. So let us say one differential equation is given. You know, right, any network we can represent in the form of inductors, capacitors are there, and in the form of a differential equation. So a third order differential equation is given: d cube y by dx cube plus 3d square y by dx square plus 5dy plus 10y equal to 10u. So, or else we can also represent, right? Third order means three dots on top of y. Like this also you can represent. Okay. Now, what is the input here? For this input is this is the input, and y is the output vector, and these x are state variables. So, what should be the how many number of state variables? Can somebody tell me how many number of state variables are required to represent this in state space model? How many state variables are required? Number of state variables. Can somebody tell me? Three. Why? Because the order is three, order of differential equations. So number of state variables is represented. That means in the circuit you have two inductors plus one capacitor, or three inductors or three capacitor, or one inductor plus two capacitor, like that. Total three memory elements are there. Fine. Then what should be the state vector? State vector is something like this: x1, x2, x3. Right? Fine. Now only one output is there, one input is there. Okay, 10u. So only one output is there, and one input is there, u, and one output is there. Fine. That means this is the input vector and y is the output vector. From here, if you see, only y is given, like y1, y2, y3 are not given. Fine. Now let us assume how to solve this. Means first assume y equal to x1. First assume y equal to x1. From here we'll start. Y equal to x1. Now y dot equal to x1 dot. Okay, suppose if you differentiate this y dot, then what you get is x dot. That means both sides I'm differentiating with respect to x. dy by d, dx1 by d. That only I'm representing in the form of dot. Okay. Now this y dot or x1 dot you say as x2, next state variable. Okay. Now again you differentiate y, then what you get is y2. If I differentiate, what you get, this is nothing but x2 dot. You got it right? First x1 is there. From here I am starting, so I am differentiating. So y dot x dot, this y dot only I am considering as x2, or x1 dot I am considering as x2. Now again you differentiate this. Y double dot is what? X2 dot. From here what is this? Y dot equal to x2. Again differentiate. Y double dot equal to x2. This you say x3. X2 dot is x3 or y double dot. Okay. Again you differentiate. What we get from here? What is the equation? Y double dot equal to x3. And now again you differentiate. Y triple dot equal to x3 dot. Okay. Can I say x4 here? Because see, x1 dot I'm saying x2. So x4 I can't say because only we require three state variables. So up to x3 only I'm going. Got it right? Okay. First initially start with y equal to x1. Then you differentiate one by one. X1 dot as some x2, x2 dot as x3, X, like this you are going. Now all these you represent in the original equation in given, input equation given. Now all this I am just representing here. Okay. In this y triple dot, if you represent all this in this, replace y triple dot is nothing but x3 dot, right? Plus 3 into y double dot. Y double dot is what? Can somebody tell me? In terms of state variables you represent, you tell. First one x3 dot and y double dot is nothing but x3 plus y dot is nothing but x2 plus y is nothing but x1 equal to 10u. Okay. Now this I'm rewriting like this. Uh, minus 10y1 minus 10y1, sorry, this is x1, right? Minus 10x1 minus 5x2 minus 3x3 plus 10u. Okay. Now I have to represent in this form, right? X equal to ax plus bu. In this form I have to represent. So this is 1 to represent in this form. This is 1. Let us say some a. And what is x2 dot? X2 dot equal to, already we have, what is x2 dot? Is what? X2 dot is nothing but, where it is? X3, right? X2 dot is nothing but x3, already we have. And x1 dot is nothing but from the previous one only, x2. So this is already where we get x2 dot equal to x3, third equation. This is fourth equation. The first original equation only I am giving in this form. Now can I represent in this way? I can easily represent. See, in this way I have to represent. So we have differential state vector equal to A into, we know the size of A should be, because we have seen, right, what should be the sizes of A matrix, B matrix, all this. Okay. So x we know x1, x2, x3 plus B matrix size also we know. What is the B matrix size? N cross M. But M is 1 only. So this is the B matrix size. And U, only one U is there. U is 1 cross 1. This is 3 cross 1. This is 3 cross 1. This is 3 cross 3. This is 3 cross 1. Now you know, right, how to write all this. For first equation x1 is first x2. Can I write like this? 0 1 0 0. Can I write like this? X1 equal to 0 into x1 plus 1 into x2 plus 0 into x3 plus 0. Okay. Similarly, what is x2 dot? What is x2 dot? X3. So 0 into x1, 0 into x2, 1 into x3. U multiplication also 0. Now what is x3 from this equation? Can somebody tell me? Minus 10 into x1 minus 5 into x2 minus 3 into x3, 10u. Is that okay? This is minus 3. Okay. And what about y? Only one output is there. That means y is 1 cross 1. So actually y equal to cx plus du. I said if active elements are there, then only. In general, active elements they don't give. So this d need will be 0. So y equal to cx. So y equal to c into x. X is how many inputs are there? Only one input is there. Only x. 1 cross 1. Then sorry, cx, right? X is three state variables, right? Input u is 1, x1, x2, x3. So y equal to cx, right? In this form. Now what should be its dimension? This one. So this is 3 cross 1. This is 1 cross 3. Now what is y? Y equal to x1 we consider, right? That is the first equation you see. We considered y equal to x1, then we started, right? Y equal to x1, right? That means y should be x1. So this is 1, 0, 0. If we keep like that, what we'll get? 1 into x1, 0 into x2 plus 0 into x3. Is that okay? How to represent? So these two represents the state space representation. Any doubts? Can somebody, if you have doubts, you can ask me. Is it clear? Others? So let me just revise it. If an equation is given like this, differential equation, you start with y equal to x1. You start with y equal to x1. Y equal to x1 you start. Y equal to x1. Then from there are words differentiate once. X1 dot or y dot you call x2. Differentiate another time. Then that is called x3 another time. That is x3 dot. Up to you have to go up to the order. Okay, na? So based on that, this is one equation, 2, 3 like this. This will be helpful to write the output equation, and these 2, 3, 4, these will be helpful to write the state equation. Okay, na? So x equal to ax plus bu, right? In this form we have to write. We are expressing like this, and y equal to cx. Okay. Now if you see here from the given differential equation, okay, if you see from the given differential equation, we can directly write here. Okay, see from here, okay, let me write here y triple dot plus 3y dot plus 5y plus 10y equal to 10u. If you see, you start in this direction. Okay, start in this direction and keep opposite sign. Take opposite sign. Some shortcut, if you see many problems, you can observe this. Take opposite sign. A matrix, if you see, you will first here you'll get some zeros. Here you will get a unit matrix 1 0 0 1. Okay, and in the opposite direction and opposite signs you will get here. So here minus 10, opposite direction minus 5, minus 3. That's what minus 10, minus 5, minus 3. Okay, this is the shortcut. Now, if you see many problems, if you solve, then this idea you'll get. Okay. Next, this 10 is there, right? So in general, this one variable, one output variable, if we have all zeros, the final one will be 10. That is the coefficient of input. What is the coefficient of input? That will go here. These will go here. Okay. And C always, depending how we represent for this, C always 1 followed by zeros. Okay. The shortcut you understood. Let me give you one more example. Just you using shortcut, you just write it. Let us see. This is the equation of y fourth order one 8y plus 9y equal to 2u. Based on what I said, from here you take and opposite. So a should be, it's a fourth order one, right? N equal to 4. So A should be a 4 cross 4 matrix. Okay. Now here and here you leave it. Here you'll get a unit matrix. 1 0 0 0 1 0 0 0 1. Okay. Then opposite direction you have to go, and these coefficients you write opposite direction and opposite sign also. So this is minus 9. Next is y dot coefficient is not there. So 0. Y double dot is minus 8, minus 9. Right? So if you write minus 9, 0, minus 8, minus 9. And these will be zeros. Okay. Similarly, what about B? I already told you. You know what should be the B's uh, what should be the order of B? It should be 4 cross 1. Anyway, you know. So all zeros you get. And the final one is the input. What should be C? C's order should be 1 cross 4. C's order should be 1 cross 4. First one will be 1, remaining one zeros. If it is in the standard form, you can directly write this. Is this okay? Anybody is having any doubts in this? Fine. Let us move on to the problem. So this is the problem it is given, right? Yeah. So if you see here, two outputs are there, one input is there, right? If you see here for this, two outputs are there, one input is there. And what is the order of S here? S plus 2 is there. That means it is a first order one, right? That means one state variable will be there. You got it right. You know, right? S is like first order, S square is second order, S cube is third order. So it's a first order one. So one state variable will be there. So let us say one state variable, that state vector, just I am representing with X. Okay. And how many inputs are there? One input. That input I am representing with U, like this. And this is 1 by 1, this is 1 by 1. How many outputs are there? Two outputs are there, 2 cross 1, y1 comma y2. Okay. Now you take from here, y1 is what? Y1 is 1 by s plus 2 into u, right? From here you can see. Okay. Now from here, what is this? S y1 plus 2 into u. That means actually you have to take in what is it, this form. Then inverse Laplace transform you have to take. So S means it's like you're differentiating. So y1 dot plus 2y1 equal to u. This is one thing. So we have x only one state vector as state variable x equal to you say y1, x equal to y1 you say. Okay, now from here what I can write, so y1 dot, sorry, y1 dot is nothing but x, right? X equal to y1, so x dot is nothing but y1 dot. So y1 dot I can write x dot plus 2x equal to u, right? We have seen earlier. So from here x dot equal to minus 2x plus u. That means x dot vector, let us say, sorry, x dot is a matrix into x and 1 matrix into u vector. Okay, now the second output you take, excuse me, just a minute, I'm sorry for this continuous meeting. Hello, hello, లేదు నేను ఇక్కడ క్లాస్ చెప్తున్నాను. Sorry for this. Fine. The second one, if you take y2 2 by s plus 2 into u, right? So this you can write 2 into 1 by s plus 2 into u. Okay. Now this everything together I can say y1 if you see. Because y1 is what? 1 by s plus 2 into u. So this everything 1 by s plus 2 into u. That means y2 is what? 2y1. But what we said y1 equal to x, I said y1 equal to x. That means 2 into x. So y1 equal to x and y2 equal to 2x. That means y vector is what? y1 comma y2 is what? 1 comma 2 is the vector. So this is the input vector, sorry, state vector, and this is the output vector. Okay, sorry, no, I wrote it wrongly, right? 1 comma 2 into y1 comma, sorry, x. I wrote it wrong. How to represent this in the form of matrix? So I can say y is y1 y2. This I can represent in the form of 1 comma 2 into x. Okay, right? No. Okay, why you represent like this 1 comma y equal to cx plus d, sorry, c is like this, right? I'm sorry. Y is in the question what they're asking. Y1, Y2 transpose they're asking. Actually, Y bar is Y1, Y2 transpose. So Y bar is Y1, Y2 transpose. Actually, how we get it should be like this, right? 1 comma 2 into y1 comma y2. We are going correct only. But what they're asking is y bar is y1 y2 complement that one. So this one. Cx, it's wrong or what? Y equal to cx plus du. 1 comma 2 we should get this one. 1 comma 2 into y, sorry, x. But y bar is complement. Okay, okay, okay. They have represented y bar like this now. That is okay. Fine, that is okay. So from here what? Y1 comma y2. If you write x, x, 2x. Okay, that is okay. Is that okay? Is that okay? See, what I am doing is actually y1 of s is 1 by s plus 2 into u of s. Right, actually this is what we can write. So s into y1 of s plus 2 y1 of s equal to u of s. If we take inverse Laplace transform, that only you'll get y1 dot plus 2y1 equal to u. But y x equal to y1 I am telling. That means y1 dot is nothing but x dot. So x dot plus 2x equal to u. That only. Okay, the step directly wrote. You can take like this inverse Laplace transform. Is it clear? Are you able to understand? Question is all are silent. That's why. Are you able to getting? Is it useful or already you know this? Because somebody has asked. That's why. Uh, Kushbu Kumar, yeah. Where is the doubt? You can ask. Unmute and ask.
Sir, in the last step, I have some doubt.
Where? Here?
Yes, yes, sir.
Y matrix representation, right?
Yes, sir.
Okay, fine. Actually, see, this is x equal to y1, right? We said, sorry, y1 equal to x. And if you see here, y2 is what? 2 into 1 by s plus 2 into u, right? So this entire thing is what we said y1. So y2 is 2y1. 2y1 means y1 is already we said x. So y2 is what? 2 into y1, that is 2x. This how we can represent, they asked in this form actually, because what they said, y equal to y1 y2 transpose. That means in this form they want to transpose, means that equal to x into 1 comma 2. If you multiply x into 1, 2 into x, that is okay, right?
Yes, sir.
Okay, but we see the standard form, but here they asked in this way, so that is okay. Okay, right?
Yes, sir.
Yeah, fine. Any other doubts? Fine. We will move on to the next question. We don't have any doubts. So this is the next question. Exponential Fourier series. This was given in GATE 2021 for 2 marks. The question is the exponential Fourier series representation of a continuous time periodic signal is defined as x of t is this one. K equal to minus infinity to infinity a k e power j k omega naught t, where omega naught is the fundamental frequency. This you know, right? Complex Fourier series representation or exponential Fourier series representation. Earlier we have seen once. Okay. Uh, and x of t and the coefficients of series are ak. The following information is given about x of t. This is the information given. X of t is a real and even having a fundamental period of 6. Okay. And the average value of x of t is 2 and ak is given. Then what they're asking, the average power of the signal x of t. That's what they're asking. So we have seen that exponential Fourier series earlier. If any periodic signal is there, continuous time periodic signal, that you can represent in the form of trigonometric Fourier series or exponential Fourier series or complex Fourier series. Both ways we can represent. So the exponential, any periodic signal, x of t is a periodic with fundamental period omega naught, and it is continuous time signal. Then this can be represented as sigma n equal to minus infinity to plus infinity cn e power j n omega naught t in terms of fundamental frequency and all. Here instead of n they have given k, that's it in the summation. Here this cn is called exponential Fourier series coefficient. Okay, so this is given by cn equal to 1 by t integral 0 to t x of t e power minus j n omega naught t. Okay, here this is the time period, it's fundamental frequency, and this is exponential Fourier series coefficient. Okay, and c naught here, c naught is nothing but when n equal to 0, then what you're getting, 1 by t integral 0 to t x of t e power 0 you'll get, means 1. Area under this is nothing but the average value, you know, right? Average value or dc component present in the signal. Okay, this is about the this one. Now what they have given, they have given x of t is real and even, and fundamental frequency 6 is given, average value of x of t is 2 they have given. That means in terms of ak, instead of cn they have just represented with ak, that's it, both are same. Now what is the average value? Average value is nothing but a naught, right? Or you can say c naught, both are same. 2 they have given. Okay, average value 2 they have given, and x of t is real and even. If x of t real and even, then cn sorry, actually here if you see the coefficients is from where to where, n varying from minus infinity to 0 then infinity. That means coefficients are what? C naught, C1, C2 up to Cn, so on. This side is C minus 1, C minus 2 up to so on, right? C minus n somewhere. If it is real and even, if the signal x of t is real and even, then what happens is, later you can check, Cn is, sorry, C minus n, anything is okay. C minus n is Cn's complex conjugate. Okay. Actually, sorry. This is the actually, if it is a complex one, this is the thing. If it is, yeah, if it is a complex one, then this one C minus n equal to Cn complex conjugate. But since it is real and even, so C minus n is nothing but Cn only. Okay, in general, how to get C minus n? C minus n is nothing but Cn complex conjugate. If it is real and even, for a real value complex conjugate is same, right? Suppose if I have like A plus JB, then complex conjugate is what? A minus JB. If it is only A, complex conjugate is same as A. That means this is nothing but this one. So C minus n is nothing but Cn. That means here they say A k is nothing but A minus k. Okay. That means what they have given? A k they have given. So A1 equal to 1, right? A2 equal to 2, A3 equal to 3, right? From 1 k equal to 1 to 3, AK is nothing but k. For k greater than 0, k greater than 3, AK is 0. Now what is A minus 1? A minus 1 they have not given, but A minus 1 is 1 because AK equal to minus AK, real and even. So A minus 2 is 2, A minus 3 is 3. Okay. A naught already we got A naught equal to 2. Now from here we need to find out the power. What they're asking, since it's a periodic signal, right? Power they're asking. If it is not periodic, it is finite signal, then energy they'll ask. Average power of the signal. So what is the average power? 1 by t integral 0 to t x of t dt, right? Over a period. Okay. So for this you need to find out the this one. You need to find out this one. This is the average power required, right? They're asking. Okay. For that you have to find out this one x of t, because ak all are given. You can find out x of t and you can find out average power. Okay. Omega naught also given. Sorry, t is given as 6. So omega naught is 2 pi f, that is 2 pi by 6. So you have to find out this one, this quantity you need to find out. A naught, A1, everything is given. So omega naught you can represent, you will get something, you can find power. Or else you can use the Parseval's theorem. That is well known, right? In Fourier series, everywhere we have seen Fourier transform and all. What is it Parseval's theorem represent? Parseval's theorem represent power in time domain equal to power in the Fourier domain, Fourier series. Okay. So 1 by t integral 0 to t x of t dt is same equal to integral k equal to minus infinity to plus infinity ak square. Okay. That means here can we write this is the theorem. From this we can directly write, because we have up to a non-zero up to we have, right? So we have a minus 3 square plus a minus 2 square plus a minus 1 square. These only we have, right? A naught square plus a3 square, a2 square, a1 square. This second, right? A naught square, all real, right? Plus 2 into a1 square, because a minus 3 equal to a plus 3, a2 square plus a3 square. A naught is 2, so 2 square plus 2 into a1 is 1, 1 square, a2 is 2, 2 square plus a3 is 3, 3 square. So what will be this? 4 plus 2 into 1 plus 4 plus 9. How much? 9, 10, 14, 28. 4 plus 28, 32 watt. Okay. Have you understood? These two ways you can find out. One is you can find out x of t, then you can find out the power. Or else simply by using a Parseval theorem, you can find out the power. So only one thing you need to know is when the signal is real and even, then coefficients Cn equal to C minus n. This only we need to know. Okay. So this, when real and even, the power I can represent how? This partial theorem only. This one, sigma k equal to minus infinity to plus infinity a k square, right? This is the power. This can represent a naught plus 2 into sigma k equal to 0 to infinity a k square. Same thing. If it is real and even. So based on that, if you have any doubts, you can ask me. Is that okay? I think it's already time, 7 o'clock. Fine. If you have doubts, you can stay back. Otherwise, you can join the other session. But before that, what I want to say is, see, you better you ask some topics which are required for you, which are useful for you. Then I will teach those topics. Otherwise, I can select from, like as I said, networks, digitals, and signals. But still you can ask from communications, random variables, random process, or else you can ask from some topics of electromagnetics, controls, or any other. If you have any doubts, you can ask. Before, just you mail me whatever questions you have, topics. Fine. If you don't have any doubts, we can stop here. Thank you. Thank you very much.